have seen in the previous sessions of transformers and in the machine case also that the paralleling operation of different type of equipments, that is the transformer also, that is the DC machines also, the paralleling operation of your induction machine also, induction generators, all that. And in the case of synchronous machines, the generator are also, which are also called the alternator, are also synchronized or also works on a parallel, which is the same reason that it is economical to have uh, suppose the requirement of some place is 50 kVA. So rather than putting a 50 kVA transformer or synchronous machine or alternator there, we can have two or three different type of different kVA ratings, such that the total requirement, that is the 50 kVA of the customer or the place, is fulfilled. It is reliable in the sense that the three different machines or four different machines will be giving the same power, but even if the single unit goes faulty, then there will be a very less total output power affected. Otherwise, if the 50 kVA transformer or 50 kVA synchronous machine is directly connected and it goes faulty, then the whole power system will go faulty. So rather than having a single unit, you can have a different type of unit so that they work in parallel. Another thing is that it is also economical to use more number of machines rather than using the single machine. It costs a lot, first of all, and secondly, it is reliable to use as many as machine you can use. So in the case of synchronous machine also, there is a thing which is called the synchronizing procedure. We can have the look on the synchronizing procedure. Synchronizing procedure is the process by which we are actually synchronizing our incoming alternator to the bus bar or to the different type of generators or the alternator working in parallel. So first condition which should be fulfilled in the synchronizing procedure is that the voltage of the generator must be equal to the bus bar or the generators working in parallel. So the voltage of the incoming generator should be equal to the bus bar. The second thing comes is the frequency. The frequency of the generator must be equal to that of the bus bar, because of the reason that if there is a change in the frequency of the incoming generator, then there may be a circulating current and there will be a problem with the synchronizing procedure. So the frequency of the incoming generator should be equal to the bus bar. The third thing, which is very important, is called the phase sequence. The phase sequence of the incoming generator must be equal to must be same as that of the bus bar. So these 3 points are very much important. So things which are very much important in the synchronizing procedure is the voltage. First of all, the voltage should be equal. Secondly, the frequency of the incoming generator should be equal to the bus bar. And the third thing is the phase sequence of the generator, incoming generator, should be equal to or should be as same as that of the bus bar. At the instant of the synchronizing, the voltage phasor of the generator and the bus bar must coincide. Otherwise, the synchronizing procedure will not happen. We will continue the synchronous machine with another very important phenomena of the machine, that is the synchronizing power. Since it is universally known that the synchronous machine runs on the speed of synchronous, or the magnetic field on which the three-phase magnetic field is rotating at the same speed the rotor moves. So it is always in the synchronism only. Somehow, if there is a disturbance, sudden disturbance in the machine, then may be possible that the rotor accelerates and the load angle increases. At that time, what happens? Due to the load angle increase, the current which will be flowing will try to come back to its original position, because of the reason that the power which is actually coming from the rotor will be getting converted into the acceleration power, which is due to the fact that the rotor has accelerated more, and that power is used, and since the rotor energy has been extracted, at that point the rotor will try to come back on its original position and will continue to run in synchronism. So that is the way the synchronous machine works. So we can have a thing called the synchronizing power. It is actually the power which is defined as the power per electrical radiance and for the rotor displacement. So we can have the formula for the power, synchronizing power, as Ps is equals to del P upon del B delta sorry, this is partial fraction. You can write this thing like this, which is equals to 3 into EF into V upon XS into cos delta. So by this formula, we can conclude that at when the load is 0 and when the no load is there, sorry, when the no load is there, then the delta would be 0 and the synchronizing power will be maximum. So for del is equals to 0, for delta is equals to 0, the synchronizing power will be maximum. And for delta is equals to 90 degrees, the synchronizing power would be 0. That means after delta is equals to 90 degree, the synchronism is lost, and at delta is equals to 90 degree, the synchronizing power is 0, and at that time it is on the verge of instability. So delta, as we know, that is the load angle. So as the load increases, the synchronizing power decreases, and so we can conclude one more point, that as the load increases, the synchronism of the machine deteriorates, and at 90 degree, when the load angle is 90 degree, the synchronizing power, there is no synchronizing power at that time, and it is on the verge of instability. And at that point, if the rotor is given a more shift towards 90 degree at that point, or we can say that if the load is increased beyond 90 degree, at that point the motor will stop if it is not having the damper windings, and the motor will not continue to run as synchronous machine, and it will tend to stop. But in this thing, one more thing comes: if the motor is accompanied with the induction motor type damper winding, in that point the damper winding will continue to run the motor, run the synchronous machine as just like an induction motor, and the torque produced by them will try to make it the load angle below 90 degrees such that it will continue to work in synchronism, and that is called the synchronous power.